Installing standard duplex receptacles with the ground pin up is generally considered code compliant in many jurisdictions. This practice aligns with both the National Electrical Code, or NEC, and the Canadian Electrical Code, or CEC. The NEC mandates that the grounding terminal of a receptacle must be connected to the equipment grounding conductor, often a bare copper wire. This conductor is, in turn, connected to the equipment grounding bus within the electrical panel. The CEC echoes these requirements, but goes a step further by specifically stating that the grounding terminal must be situated at the top of the receptacle. This placement is intended to facilitate easier inspection and maintenance. Beyond these national codes, numerous local building codes also mandate the ground-up installation of standard duplex receptacles. For example, some city building codes explicitly require receptacles to be installed with the grounding terminal at the top. Consequently, unless a specific local code dictates otherwise, installing standard duplex receptacles with the ground-up orientation is widely accepted as compliant with electrical codes. To further clarify the reasoning behind this practice and its importance, let's delve deeper into the function of the grounding system and the rationale for the ground-up orientation. The grounding system in an electrical installation serves as a crucial safety measure. Its primary purpose is to provide a low impedance path for fault currents to return to the source, typically the electrical panel. This low impedance path facilitates the rapid tripping of a circuit breaker or fuse, effectively disconnecting the faulty circuit and preventing potential electrical shocks or fires. The equipment grounding conductor, or EG, plays a vital role in this system. It connects the non-current carrying metal parts of electrical equipment, such as appliance chassis and metal enclosures, to the grounding bus in the electrical panel. This connection ensures that if a fault occurs, such as a live wire coming into contact with the metal enclosure, the fault current will flow through the EGC back to the source. The low impedance of the EGC allows a large amount of current to flow, quickly tripping the overcurrent protection device and energizing the circuit. Without a properly functioning grounding system, a fault could cause the metal enclosure to become energized, posing a significant shock hazard to anyone who comes into contact with it. The ground-up orientation of the receptacle contributes to safety in several ways. Firstly, it provides a visual cue to electricians and inspectors that the receptacle is properly grounded. The grounding terminal, being located at the top, is easily visible and accessible for inspection. This allows for quick verification that the EGC is securely connected to the receptacle. Secondly, the ground-up orientation helps to prevent accidental contact with the live terminals during installation or maintenance. When inserting a plug into a receptacle, it is natural to align the ground pin first. With the ground pin at the top, there is less chance of accidentally touching the live terminals with your fingers or tools. This is especially important when working in dimly lit or confined spaces. Thirdly, some argue that the ground-up orientation can help to prevent objects from falling onto the live terminals of a partially inserted plug. If a metal object were to fall onto a plug that is only partially inserted into a receptacle with the ground pin at the bottom, it could potentially create a short circuit between the live terminals. However, with the ground pin at the top, the object would likely contact the ground pin first, which would not create a short circuit. While this is a less common scenario, it is still a potential safety benefit of the ground-up orientation. It is important to note that the NEC does not explicitly require receptacles to be installed with the ground-up orientation, except in specific cases such as when receptacles are installed in a face-up position on a countertop. However, the NEC does require that the grounding terminal be connected to the EGC, and the ground-up orientation is a widely accepted practice that helps to ensure compliance with this requirement. Some argue that installing receptacles with the ground pin down is just as safe, as long as the grounding terminal is properly connected to the EGC. However, the ground-up orientation has become the de facto standard in many jurisdictions, and it is generally recommended to follow this practice unless there is a specific reason not to. In addition to the safety benefits, the ground-up orientation also provides a more consistent and aesthetically pleasing appearance. When all the receptacles in a building are installed with the same orientation, it creates a more uniform and professional look. This is especially important in commercial and institutional buildings, where aesthetics are often a consideration. To summarize, installing standard duplex receptacles with the ground-up orientation is a widely accepted and generally code-compliant practice. It provides several safety benefits, including easier inspection, reduced risk of accidental contact with live terminals, and a more consistent appearance. While the NEC does not explicitly require this orientation in most cases, it is generally recommended to follow this practice unless there is a specific local code requirement to the contrary. The grounding system is a critical safety feature in electrical installations, and the ground-up orientation of receptacles is one small but important detail that contributes to its effectiveness. By adhering to this practice, electricians can help to ensure the safety of people and property. Furthermore, consider the implications of not following the generally accepted practice. Firstly, deviations from established norms, even if not explicitly mandated by the NEC, can raise questions during inspections. Inspectors are accustomed to seeing receptacles installed ground up, and any deviation may prompt closer scrutiny, potentially leading to delays or required corrections. Secondly, consider future maintenance and modifications. If subsequent electricians are not aware of the unconventional installation, they may assume a fault in the grounding system or incorrectly diagnose other issues. This can lead to unnecessary troubleshooting and potential safety hazards. Thirdly, the ground-up orientation has become ingrained in the training and practices of electricians. It is a commonly taught standard that ensures consistency and reduces the likelihood of errors. Deviating from this standard can introduce confusion and increase the risk of mistakes, especially for less experienced electricians. Fourthly, it is worth noting that some manufacturers design receptacles with features that are optimized for the ground-up orientation. For example, some receptacles have markings or labels that are more easily visible when installed ground up. Additionally, the internal wiring and construction of some receptacles may be designed with the ground-up orientation in mind. Fifthly, the ground-up orientation can also be helpful in identifying dedicated circuits. For example, some electricians may choose to install all receptacles on dedicated circuits with the ground pin up, and all receptacles on general-purpose circuits with the ground pin down. This can provide a quick visual indication of which circuits are dedicated, which can be useful for troubleshooting and maintenance. To delve further into the specific code references, the NEC Article 250 covers grounding and bonding requirements. While it doesn't explicitly mandate ground-up installation for standard receptacles, it emphasizes the importance of a properly installed and connected equipment grounding conductor. Article 406.4 covers the installation of receptacles, and it also doesn't explicitly mandate ground-up installation in general applications. However, it does specify that receptacles installed in a face-up position on countertops must have the grounding terminal located at the top. The SEC, on the other hand, provides a clearer directive regarding the ground-up orientation. It specifically states that the grounding terminal of a receptacle must be located at the top. This requirement is intended to enhance safety and facilitate easier inspection and maintenance. It is also important to consult local building codes and regulations, as they may have additional requirements or restrictions regarding the installation of receptacles. In some jurisdictions, local codes may explicitly require ground-up installation for all standard duplex receptacles. Furthermore, the authority having jurisdiction, or OJ, has the final say on whether an installation is code compliant. The AHA may interpret the NEC or CEC in a particular way, or they may have their own local requirements that must be followed. It is always a good idea to consult with the AHA before starting any electrical work to ensure that the installation will be code compliant. In conclusion, while the NEC does not explicitly mandate ground-up installation for standard duplex receptacles in most cases, it is a widely accepted and generally code-compliant practice. It provides several safety benefits, including easier inspection, reduced risk of accidental contact with live terminals, and a more consistent appearance. The SEC, on the other hand, does explicitly require ground-up installation. It is always a good idea to consult with local building codes and the AHA to ensure that the installation is code compliant. By following these guidelines, electricians can help to ensure the safety of people and property. Let's consider some practical scenarios where the ground-up orientation can be particularly beneficial. Firstly, in healthcare facilities such as hospitals and clinics, electrical safety is of paramount importance. The ground-up orientation of receptacles can help to reduce the risk of electrical shock to patients and staff. Secondly, in schools and daycare centers, where children may be present, the ground-up orientation can help to prevent accidental contact with live terminals. Thirdly, in manufacturing facilities and industrial plants, where heavy machinery and equipment are used, the ground-up orientation can help to ensure the proper grounding of electrical equipment and prevent electrical hazards. Fourthly, in residential buildings, the ground-up orientation can provide a more consistent and aesthetically pleasing appearance. Fifthly, in commercial buildings, such as office buildings and retail stores, the ground-up orientation can help to create a more professional and uniform look. In addition to the safety and aesthetic benefits, the ground-up orientation can also make it easier to troubleshoot electrical problems. When all the receptacles in a building are installed with the same orientation, it is easier to identify potential issues such as loose connections or damaged wiring. Furthermore, the ground-up orientation can help to prevent the miswiring of receptacles. When the grounding terminal is located at the top, it is less likely that the hot and neutral wires will be accidentally reversed. This can prevent electrical shocks and fires. It is important to note that the ground-up orientation is not a substitute for proper wiring and grounding techniques. Even if the receptacles are installed with the ground pin up, it is still essential to ensure that the wiring is done correctly and that the grounding system is properly installed. However, the ground-up orientation can provide an additional layer of safety and protection. In summary, the ground-up orientation of receptacles is a valuable practice that can enhance electrical safety, improve aesthetics, and facilitate troubleshooting. While it is not always explicitly required by the NEC, it is a widely accepted and generally code-compliant practice that is worth following. By adhering to this practice, electricians can help to create safer and more reliable electrical installations. Now let's address some common misconceptions regarding receptacle installation. One common misconception is that the ground-up orientation is solely an aesthetic preference. While aesthetics are a factor, the primary reason for the ground-up orientation is safety. As discussed earlier, the ground-up orientation provides several safety benefits, including easier inspection, reduced risk of accidental contact with live terminals, and a more consistent appearance. Another common misconception is that it is acceptable to install receptacles with the ground pin sideways. While this may be technically possible in some cases, it is generally not recommended. The ground pin sideways orientation can create confusion and increase the risk of miswiring. Additionally, it can make it more difficult to insert plugs into the receptacle. A third misconception is that the ground-up orientation is only required in new construction. In reality, the ground-up orientation is recommended for all receptacle installations, regardless of whether it is new construction or a renovation project. A fourth misconception is that the ground-up orientation is only important for 15-amp receptacles. In fact, the ground-up orientation is equally important for 20-amp receptacles and other types of receptacles. A fifth misconception is that the ground-up orientation is not important if the receptacle is protected by ground fault circuit interrupter, or GFCI. While GFCIs provide an important layer of protection against electrical shock, they are not a substitute for proper wiring and grounding techniques. The ground-up orientation can still provide additional safety benefits, even if the receptacle is GFCI protected. In conclusion, it is important to dispel these common misconceptions and to understand the true purpose and benefits of the ground-up orientation. By following the proper guidelines and adhering to the electrical code, electricians can help to ensure the safety of people and property. Finally, always consult with a qualified electrician or electrical inspector if you have any questions or concerns about receptacle installation. Electrical work can be dangerous, and it is always best to leave it to the professionals. A qualified electrician will be able to ensure that the installation is done safely and correctly, and that it complies with all applicable codes and regulations. They can also provide valuable advice and guidance on the best practices for receptacle installation in your specific situation. Remember, safety is always the top priority when it comes to electrical work. Do not attempt to perform any electrical work unless you are properly trained and qualified. And always follow the electrical code and consult with a professional if you have any doubts.